read any number of books, you really do not get enough knowledge. You have to perform experiments and then learn from that. So let me quickly go and show you a very small experiment with, and every day I will spend about 5 minutes or so, very small experiment, and then perhaps you can ask. It will be wonderful if I can interact with you, but due to other technical problems, maybe I will try to explain to you at the end of the experiment the physical reasoning behind that also. So are you ready for the experiment? Can we go now? Okay. So I have here two cylinders. Okay, the cylinders are of the same height, same diameter, and I can assure you same mass. This one is a solid cylinder, as you can see, made of wood, and this one is a brass cylinder, metal cylinder, hollow cylinder. Okay, so this is hollow, this is solid. They are the same height, same diameter, and same mass. How do I say they are same mass? They are same mass because I have put some extra nails and metal here and made sure by putting on a balance that they both are of the same mass. So now what I am going to do is I have here an inclined plane, and I am going to run a race between these two cylinders. I am going to put them both here at the top, and then I will leave them together at the same time. So I want to know which one, what is going to happen if I leave the two cylinders at the same height, okay, on an inclined plane. We all know they will roll down and come to the bottom. I want to know what is going to happen. This I want to ask in a manner you are all very familiar all through, right from your LKG. And what is that? A, both will come together. Answer B, the hollow cylinder will come first. Answer C, the solid cylinder will come first. Answer D, none of the above, maybe, I don't know. Are you ready? Shall we do the experiment quickly? So I'm going to leave them from the top. I don't know how many of you are saying A, how many are saying B, and how many are C, and maybe there are some D's also, I don't know. Let us try. So I'm going to put them at the top and release them. You can see what is happening. Who is coming first? Solid cylinder. Let me try once more. Every experiment should be tried more than one time to make sure it happens in the same way. I release. You can see the solid cylinder only comes first. Last time. Right. So, do you know the explanation? Can anyone tell me? Some of you might know, I am sure. Many of you may know. This is a very simple problem. You have, both of them have the same potential energy to start with, mgh. Both of them have the same potential energy. I release them from the same height. But you find the solid cylinder comes first and the hollow cylinder comes later. Why? Because here there is a combination of motion. There is a translation of motion. I put it here at this end and it comes to the bottom. So there is a translation from one place to another. Second, they are not coming sliding. They don't come sliding. They come rolling. That means there is going to be rolling motion or rotation in addition to translation. So the total energy mgh will have to be shared by two more activities. One is translation, therefore there will be a energy associated with the translation motion, which we all know, half mv square. In addition, there is going to be a rotation. For rotational kinetic energy, you all know we use half I omega square. So the total mgh, maybe I'll write on the board, the total mgh is going to be shared by two terms. mgh is equal to half mv square plus half. This is kinetic energy of translation. This is rotational kinetic energy. Two energies are involved. Now let us see, is there any difference? If I take m1 for the solid cylinder and m2 for the hollow cylinder, if I take m2 for the hollow cylinder, you find there is some difference. What is the difference that you know already about these two materials, one solid, one hollow? We all know what is I here? The moment of inertia, right? What is moment of inertia? The inertia associated with rotational motion. So I know is different for the two materials. I, moment of inertia of a hollow cylinder, many of you will know, is mr square, because most of the material is only at a distance r from the center. So it is mr square. And I for the solid cylinder, because there is a continuous distribution, is going to be half mr square. So I1 will be mr square and I2 will be half mr square. So this makes the difference. That means this mr square will have some energy, and because of the half factor, this will have only half that energy, the solid cylinder. So what is going to happen? Out of the total potential energy, which is constant, these two are equal because they come from the same height, and m1 is equal to m2, h is equal to h in both the cases. So you find out of the total potential energy, more energy is used for rotational kinetic energy for the hollow cylinder. Less energy is used for rotation by the solid cylinder, and therefore when you subtract more, this will become less. When you subtract less, this will be more. Therefore the velocity v1, v2 will be different, and you know the solid has got more kinetic energy of translation, so it will come faster. So it is not necessary only to know about moment of inertia and all that, but you must be able to apply to a new situation when there is a problem posed. So if I have two cylinders having same mass, same dimensions, etc., if I release them, one comes faster than the other, so you must be able to reason it out from known physics principles. So that is the importance of the demonstration. So I will